yesterday or whatever our last time was, did we stop at on page 6 at 3B?
Yeah.
Pretty impressed I remembered that. Okay. So we've got the equation 2x squared minus 9x plus 7. Right?
Yes.
Yeah.
Now, we got a couple of choices on this problem. Actually, we have 3 choices. It's a quadratic. So what are our choices? Quadratic formula, which will always work. So if that's your number 1 choice, that's awesome. It will work on every problem. What are our other choices? We could factor it. Now what's the problem with that? They don't always factor, but if you can tell it's factoring, sometimes ones like this look too hard and you don't want to mess with it. And then what's the third option? Completing the square. Now, on this problem, if I get to pick, and we get to pick individually, I wouldn't complete the square. Because the first step to completing the square is you have to get rid of this number. And what's going to happen here and here then? You're going to have fractions that you're going to have to be taking half of and squaring and doing all that stuff. So I'm not going to complete the square. Did you notice that this one actually does factor? Now, does everybody understand you have to have a 2x and an x, right? Because that's how you're going to get 2x squared. Now, how do I get a 7? You don't have a choice. It has to be a 7 and a 1. So how I put them up here, the order matters, so I'm going to check and see if I have the right order. What does this give me? Negative 2x. And this gives me negative 7x. Does that add up to negative 9? So I got it. So I'm going to set each of these equal to 0. And my answers are 7/2 or 1. Now, what if I did that with the quadratic formula? What would my answers come out to be? 7/2 and 1. The answers are the answers. They're not going to change on how you do the problem. Okay? Now, I talked to Mr. Miller yesterday, told him how much you remembered about I squared is negative 1 and all that. And he said, can they factor? And I said, I don't know. And he said, they better know how to factor. So, if this is confusing to you, go back and review it a little bit. But remember, you can always use the quadratic formula to solve it if it's an x squared equation.
Can we do the quadratic formula that one?
Why?
I don't know, my answer is not.
Your answer didn't match. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's see, what have I got under here? I got that's 81 minus 56, which is 25. So I have 9 plus or minus 5 over 4. So what's 9 plus 5?
14.
Over 4?
7/2.
14 fourths reduces to 7/2. And then 9 minus 5 is 4 over 4
I see
is
where I went wrong.
1.
Thank you.
Okay, next, this little review problem. We did one of these yesterday. How do I simplify that guy? Foil. Straight foil problem. So first comes first. Outsides, insides, and less. And these two can be put together, right? They're like terms. So what's a negative 12 and an I said 12. Negative 21 and 8. What's negative 21 and 8? Negative 13, thank you. And how about that? Negative 14i squared. Paul? Well, it wouldn't be 15. Because remember, you're multiplying, Paul.
14.
So it'd be positive 14. Added to the 12 would make 26. B is kind of the same thing, only bigger. We did one of these yesterday too. Does anybody remember how we handled our division problem yesterday? What did we do, Miss Swanton?
Multiply by the conjugate.
And what do you mean by the conjugate?
By the bottom, so it's like the opposite, so you multiply 3 plus 2i.
3 plus 2i, that's called the conjugate, just like she said. And we have to do it to the top and the bottom, kids. Don't do it just to the bottom, we're going to do it to the top and the bottom. So now we have two big foils. Right? So here we go. First, I'm starting on the top. First, outside, inside, last. And then on the bottom, first, outside, inside, last. Now, what always happens on the bottom?
Cancels.
Yeah, if we do this right, those should always cancel on the bottom. What do I have left on the bottom then? 9 minus 4i squared. And what's 9 minus 4i squared? What's this?
4.
That would be plus 4. Remember, I squared is negative 1, so that's going to be a plus 4. So my bottom is just 13. Now, that won't happen on the top. Let's see. That makes a 31. Okay, now what about that? That's negative 14. So that makes a 1. Nothing there, obviously, nothing cancels in that problem. But even if it had been 13 plus 31i over 13, you still can't cancel. The rule is you have to be able to cancel in all 3 places. So that doesn't simplify. If you have this, now you can simplify. Do you see the difference? Now I can take this into this and this into this, and my answer is 1 plus 2i, if it had been that. But if you can only cancel in one place, doesn't work. Okay?
What about for square roots? Does that work? Are you allowed to cancel there if you have like, say you have like...
If you have something like 5 plus 10 root 7 over 25.
Yeah.
Yes, you can cancel because you have this number, and this number all have something that will cancel out. But if you had 5 plus 3 root 7 over 25, you cannot cancel these because you can't cancel these. You have to be able to do all 3 spots. Ready, okay? Mm-hmm. All right. Now we're moving on to P7. At this point, gang, you should have you should be able to have done all of the homeworks through P6. So if you're back in P2, or heaven forbid, if you haven't started yet, you need to get busy because this homework's gonna be due next week. We're getting close. Okay, we'll have a test next week. I'm not sure exactly what day, but we're getting close. Okay? So here's what I need you to do. I need you to open up your minds completely because we are going to do this problem differently than you have done it in the past. And you say, oh, why, Mrs. Ford? Why do you make me learn something different? Because you are pre-calculus students. And this concept, believe it or not, is a big one in calculus. So we're gonna start thinking about it like a calculus student thinks about it. And it's really, really simple. Sit there for a second and just watch. If I said to you, how far apart are 4 and 7? You would all say 3, right? And how did you get 3? You subtracted. So you took 7 minus 4. You could have taken 4 minus 7. Sometimes we do that. But if you did it that way, you'd have to take the absolute value because distance has to be a positive number, right? But either one of those are equal. It doesn't matter whether you do 4 minus 7 or 7 minus 4. So notice this number right here, this represents the distance between 7 and 4. Isn't that what this is doing? This is finding the distance between 7 and 4. So when I look up here and I see this means the distance between 7 and 4, what does that mean? The distance between x and 2. I don't know where x is, but I do know that the distance between x and 2 has to be more than 3. Okay, now wait a minute. This distance has to be more than 3. What would be this boundary right here? If this distance has to be 3, what label could I put here? What number?
6.
Okay, now be careful. I'm going to put a 5. And you're going to say, oh, Mrs. Ford, that distance isn't more than 3, so I'm going to put an open dot. And I'm going to say all these numbers have a distance more than 3 away from 2. Would you agree with that? Now, here's the problem. Could x be back here? Could that distance be more than 3?
No. Yeah.
Oh, yeah. There's a number over here that's 3 units away. What is that number that's 3 units away?
-1.
-1. Shaded all of these then? So my answer is everything from negative infinity to -1, or everything from 5 to positive infinity. Now, that was question number 1. Write this down. Write this down. You don't, maybe it hasn't sunk in. Look, we got tons of examples. We're going to get it. Don't you worry. We're going to get it sorted out.
Why wouldn't that 3 have to be positive for it to like go the other way?
It's the number of units, not.
What, this 3 here?
Yeah.
Okay, that is, this says the distance between x and 2 is more than 3. So if I'm 2, I could have a number over here that's 3 units away. But I could also have a number over here that's 3 units away.
I got you.
Right, on either side of me. Now, to kind of help you start making sense of this, notice what I did. Maybe it hasn't sunk in yet exactly why I'm doing what I'm doing, but look what I did. I drew a number line, and what was the first number I put on my number line?
2.
Right in the middle of my number line, I put the middle number in the problem. See how there's 3 things in the problem and that's in the middle? Now wait a minute, that's a -2. Did I put a -2 in the middle? No, I picked the opposite. The absolute, well, I took the opposite. That's what I want you to think of it. Take the opposite. Remember when we did circles? Where is the center of this circle, you guys? -2, +1. It's the same concept. It's the opposite. So that said x -2, so I put a +2 there. Okay? So the first thing I did was put that 2 on the number line. How did I get 5? What did I do to get 5? I added 3. What did I do to get -1? I subtracted 3. So if you think about the steps you did in the problem, even if it's not making sense yet, you can do another problem. The next problem says x plus 5 is less than or equal to 6. So here's my number line. I have to put a number right in the middle of the number line. What number is going to go in the middle of my number line? Paul? Careful.
-5.
-5. Yep, we're going to put -5 because we put the opposite. Now I need to establish 2 points on either side of that. How am I going to figure out what those 2 points are? What am I going to do? I'm going to add 6 and I'm going to subtract 6. So when I add 6, I get a 1. And when I subtract 6, I get a -11. Now there's a couple of differences about this. First of all, these dots are going to be colored in. Does that make sense to you? So we're going to go ahead and color the dots in. Secondly, over here, I shaded out here because this said the distance was more than 3. So I had to be farther away than 3 units. This one says the distance is less than 6. So I want to be closer to my middle number. So instead of shading out here on the ends, where am I going to shade?
Middle.
In between them. So my answer is -11 to 1. Okay, so let's talk about that again. I started by putting a number right here. What number did I put there? The opposite of that. Then how did I get my dots? I added 6 on one side and I subtracted 6 on the other side. Okay? All right, I want you to go to lunch now. I want you back here in your seat. See these 2 right here? They are bringing in Kleenex because they were tardy from lunch. You want to be on time, you got to be in your seat at 12:22. In your seat at 12:22. You can leave